Good morning. Welcome back to my lecture on cables, mining cables in mines, 53, lecture number 53. So, in this we will be as usual, but in addition to that we will understand so what are the conducting materials in cables. Conducting materials, different type of conducting materials of cables. Sorry, 1 minute. Sorry, pen. Conductors, and the materials of cable. Then what are the different physics behind the faults and failures and operation. In a nutshell, we will be talking about the electrical, thermal and mechanical. These are the three things. The conductor should be good conducting, insulator should be good insulating material, there should be good thermal conductivity, it should not burn, temperature should not rise. Mechanical means it should be having tensile strength, abrasion, because the cable has to be flexible and sometimes it has to continuously roll on roll. So, let's start about the conductors first. These are the what are the different conductors in cables. So, there could be copper and aluminum, both are good conductors, but coppers are better but very expensive. Copper is little expensive, aluminum is cheaper, but it has only 61%. It is cheaper as well as lighter. So, this is cheaper but lighter, but conductivity is less. Aluminum, because there are copper and aluminum, these are the two main conductors used in cables. It has high conductivity, it is flexible, it is expensive. It has 61% of the conductivity, it is lighter, cheaper, but less flexible. So, considering the cheap, if there is no flexibility required, go for aluminum, otherwise go for copper. So, this is how, if you have a fixed current, the cable conductor cross section, conductor decided primarily by conductor, the current density, remember. Suppose you have to have 100 ampere of current, there is a maximum current density, that means current per unit area, that is permitted. This is permitted, maximum allowed for design. So, current density, which is ampere per meter square. If it is more than that, it cannot tolerate, it will heat up. So, therefore, for fixed current I, if you need SU as the copper, the aluminum area will be about 159 times, 169, 1.5 or 1.6 times the copper area required. So, the volume of the aluminum will be more. So, therefore, you need large area of that means thicker conductors of aluminum. So, this is how you relate the conductors. So, if you look at the conductors arranged in a cable, they are not arranged at one unified conductor. That means, suppose the area required is A, it is not one conductor, it is stranded, as you can see. The stranding improves many things. Number one thing is it will reduce the eddy current loss. Number two, it will increase the mechanical strength. So, and it will increase the flexibility. So, stranding is a must. So, stranding means to make the same conductor area, we have small conductors, it is easy to manufacture and you make them like this. This is called stranding. So, there are multiple fine strands, that is how conductors are made. So, that will reduce, number one is it will be strong, number two it will reduce eddy current loss, that means the power loss here, but without reducing the increasing the resistance, because the effective area will be same. So, it is how it is done by cold drawing, which will reduce diameter, and it is easy to manufacture also. Thin conductors easy to manufacture. Annealing restores flexibility, it will restore the flexibility. Annealing means heating and cooling. So, this makes it more mechanically strong. So, the mechanical inside, that means the force per unit, that means stranding improves flexibility without sacrificing the strength. You can see that, because this is the modulus, Young's modulus, force by unit area, the stress. This is the stress. So therefore you need to strand. Conductors are never used solid, it is used as stranding in strands. So when you have thermal effects, if you look at, so thermal means heat. So how heat is generated? Heat is primarily generated by I square R loss, because even if it is copper or aluminum, even the conductivity is good, the resistance is there. So if you pass a current I, whatever may be the resistance, small resistance, there will be I square R heat generated. This is power generated and multiplied by T, this gives you heat. So this heat has to be dissipated. Dissipated through this insulating material. There are insulating materials, so therefore the resistive heating has to be, so higher current, higher heating. So what will happen if the insulation is subjected to high heat, the insulating property degrades. So insulator or insulating material, which are basically polymer carbon chains. So when the heat is increased, if you increase the temperature or heat, the conductivity will decrease. Conductivity of if this should be insulation will reduce. Therefore the insulating property will be affected. Therefore heat has to be dissipated quickly. So this is called American wire gauge system. So this is, the diameter, if you keep on reducing between two steps, the diameter is 92. So this is called a standard American, AWG means American wire gauge system. You use this to strand the cables. So this is a standard and it is based on geometric progression. So cross-sectional area and current capacity, they are related, as I said. So area determines current carrying capacity and mechanical strength both. The area is, so diameter is area, the relationship pi d square by 4. So small increase in diameter gives large increase in area. So the American standard gauge in geometric proportion. So geometrically it will become in power law. In number strand, American standard, first standard, second standard, third standard, like that, the area will exponentially increase and the current carrying capacity will increase. As you can see, these are different standards, standard 1, standard 2, standard 3, standard 4, like that, how the area is increasing. So area of the conductor depends upon the current carrying capacity, because the current density allowed is fixed. This is ampere per meter square. This is current density. Why current density is fixed? Because the material has a property, current density square into the unity length of resistance gives you heat generated per volume. That means J square into R per unit length, because conductor is long. So R per unit length is R ohms per unit length meter, and if you multiply, that gives you heat or power, heat power per unity volume. So this is fixed. So therefore this is also fixed, because it has to dissipate outside. This conductor heat has to be dissipated to the outer conductor. Therefore this is fixed. So these are some of the practical design. If you increase the area 4 times, resistance will decrease. If you double the diameter, what will happen? Area will increase 4 times and resistance will decrease, because resistance is proportional to rho L by A. Rho is the resistivity, L is the length, A is the area. So if you increase double the diameter, resistance will decrease by 4. So what are the operational 3 gauge step? 2 into change, 10 steps, 10 into change. So this is how it is related. So this is irrelevant, so don't worry about it. So what happens, what to do? So grounding requirement, every power system needs to be grounded. Therefore there is a 50% of power conductor needs to be grounded. In the distribution system, grounding is required. Grounding is required. Grounding reduces the chances of shock over voltages, because it will go to the earth. So therefore this limits the minimum size, okay, of the ground. You cannot say ground conductor sometimes have to be thicker. If you see 3-pin plugs, the middle one is more thick. So the side one, so this is small ones, 3-pin plug. If you go for 3-pin plugs, there are 3 pins. These 2 are thin, and this is the grounding which is thick, because all the fault current has to pass through this. So if the equipment, because it is going to the equipment, so this is the equipment, ground wire also go to the chassis. So, this goes to the power, maybe motor. So, this is the chassis. If there is any fault here, it has to come through this earth, and if there is a fault, it should not come through the return, it should come more. So, that means if this is phase, this is neutral, and if there is a fault, there is a chance that it will go through the neutral, or so what will happen, this should carry more current. So, less resistance or more thicker. Therefore, if there is a grounding conductor, then the thickness has to be limited, it cannot be less than certain things. So, these are, again I am saying, many small wires instead of a single solid conductor twisted into strands. So, they become rope type like structure. So, 37 wires per strand, 7 strands, 249 wires together, cross sectional area, sum of all individual wires. So, this happens, more small wires, higher flexibility. When there is stranded, instead of solid, stranded rope like structure, it will have more flexibility. Fewer large wires, higher tensile strength. Again, if it is flexible, then tensile strength reduces. So, but if you have solid, the tensile strength is more. So, when this increases, this might decrease. So, you have to make a trade off. So, these two have to be trade off, flexibility versus mechanical strength. Okay. Then comes insulation. So, till now the conductor is decided by the cross section because of the current density. It is stranded to increase the flexibility. So, there has to be trade off. So, now come to the insulation. So, what is the purpose of insulation? There are two things. One is it will have electrical insulation, that means two cables. If there are two cables like this, they should be insulated from each other, as you can see, otherwise there is short circuit. So, this is called electrical insulation, and they are achieved by how? They are achieved by introducing dielectric. So, these mediums are dielectric mediums. You can see this is insulator, this is insulator, dielectric. That means it will break down, not break down. If there is a dielectric, it will not break down. The conductor will not touch, that is one thing, and also the dielectric strength, where the epsilon r will be more, the breakdown will also prevented. For the same voltage with introduce dielectric, you will reduce the breakdown, you increase the breakdown strength. So, therefore, it has to be insulated. And second property of insulation is it should be a good conductor of the heat generated here. So, there are two things here, you can see insulation, the purpose is voltage stress to reduce heat and mechanical damage. So, these are the three things. Protection is first of all voltage stress, this is the first, then it should also protect against heat, external heat, that means the mining there may be fire outside, temperature might be more, and it should also protect from mechanical damage. So, it ensures safety from electrical shock and separation of power and grounding circuit. So, these are the prime, that means the power circuit and ground circuit has to be insulated, number one, it should not be exposed to outside and it should have sufficient mechanical strength, and also it should be a good conductor of the heat from inside, heat to be dissipated, at the same time it will prevent the inside conductor to be affected from the external damage. So, when heating is done on the cable, if there is a cable insulation, as I said earlier, it will soften the insulation, that means it will reduce the field strength. That means, if there is a particular insulation, there is something called breakdown strength. Breakdown strength is written as voltage per meter, it is equal to the electric field, and for air it is 33 kilovolts per centimeter. So, that means, if you are in a air, if this is 1 centimeter, to break it down completely, make it conductor, you have to apply voltage which is more than 33 kV. So, if you apply a voltage which is more than 33 kV, so if you put insulators here, this 33 kV will increase. So, by putting insulators with proper dielectric strength epsilon r, this breakdown strength will increase. So, what happens? So, this is called breakdown strength. So, breakdown strength increases because of insulation material, or E breakdown, let us write, which is in kV per centimeter, you can say. So, that increases because of insulation. So, this strength, if you heat the insulation, the insulator materials will release electrons and ions. So, these ions will become conducting and the loss of strength will be happening. That means, the breakdown strength will go down. At the same time, it will cause aging. If you heat a particular insulation, it will become brittle. That means, the mechanical strength will also reduce. It also leads to reduction in tensile strength, it will elongate because expand, and it will also decrease the electrical resistance. Okay. So, what are the heat sources? Heat sources are ambient environment and I square R losses in the conductor. That means the heat sources are both. That means inside it is I square R loss. If this is the conductor and this is the insulator, this is insulator. So, external heat because of mines operation etc., and internal heat, both are heating the insulator. So, insulation heat will go up. So, therefore, the insulation should have the strength to bear this heat. So, what are the different insulation material? Most popular is this XLP called cross linked polyethylene. It has got good heat conductor, also it has good insulation property and it has good mechanical strength. It has all three. Then there is neoprene, then styrene-butadiene rubber and ethylene propylene. These are long chain carbon hydrocarbons. They are called long chain hydrocarbons. It is like plastic, but they are in a particular way it is done. They are called long chain hydrocarbons. So, the whole characteristic of this neoprene, styrene, butadiene rubber, ethylene, propylene rubber, XLP, at least few of them you remember, and this should have good thermal resistance and it should have mechanically durable thermal resistance. It should not break down with heat. That means it can withstand the temperature. It is called thermal resistance, withstanding the temperature, withstanding thermal stress. What is thermal stress? Thermal stress is heat flow which is related to temperature gradient. Okay. So, therefore, it should withstand that kind of heat. The property of insulation should not change. Insulation means high resistance. So, flexibility means mechanical strength, mechanical durability means with abrasion etc., heat and cold treatment it should be mechanically strong. So, this has to also withstand the test voltage, because before the cable is released for mining operation, it has to be standardized. There are several standards for cable testing. The cable has to satisfy all the over voltage, short circuit, heat, everything, because heat and fire are most important things in mines. If the cable gets heated up and catches fire, the fire should be extinguished automatically. It should not spread fire. So, these are the very tough standards, including the fire standard, fire hazard standard, cable insulation standard and many more. So, cable ratings are related to withstand the test voltage. Then there are phenomena like partial discharge. Partial discharge means if there is a cable, there may be small discharge happening through the insulation. If there is a water moisture ingress etc., sometimes in mining there is lot of water etc., or there is small damage etc. So, what will happen? There will be ingress, and there are cable joints. We cannot have infinitely long cable. So, after some time you may have to have cable joints. If there is cable joint, near the joint there may be partial discharge. Also there may be corona. Corona is something, it is called temporary breakdown on the surface of the conductor. That means if there is a conductor, suppose this is a conductor and it is irregular because you have stranding. So, there is irregular conductor. So, on the surface there is electric field which is coming in contact with air. Air may have moisture. Air has a breakdown strength of 33 kV per centimeter, but it may reduced in the presence of moisture, because inside mine there may be moisture, and if the conductor is exposed or the conductor is having the cable insulation is broken, it will continuously break down the air. Once it is break down, this is called corona. So, this corona happens, partial breakdown of the air and ozone. So, once there is a breakdown, if there is oxygen, the oxygen, what happens? The oxygen becomes ozone, because oxygen molecule breaks down, it combines ozone, and ozones are highly inflammable. So, these are the few things. Additional things like dust also around that becomes ionized. If there is a continuous breakdown around the conductor, corona, khach like that sound will be there, partial discharge. So, what will happen? The oxygen will ionize, it will make ozone. At the same time, dust particles will also ionize, this will become ionized dusts. Both of them are not good, because that might lead to fire hazards. Ozone is very inflammable, at the same time it will oxidize everything, because it is unstable. O3 is unstable, it quickly breaks down into O2 plus O. So, what happens when the O oxidides? If there is a O ion, this O, this will immediately combine with things, oxidize, and it will generate fire. So, therefore, we should make sure there is no void in the insulation, and there should not be any chemical attack. If the outer insulation is subjected to chemical like acids etc. inside a mine, what will happen? It might create holes, and those holes will be responsible for corona effects and partial discharge. because the conductors will be exposed. Therefore, these are some of the things which are very important for insulation. It should also chemical resistant. This is also important. So, these are behavior of advanced insulation. So, how it is done? It is the insulation is put in the form of a cable jacket. The cable jacket will have also a metallic armor. So, this armor is responsible for external strength. So, this provides this jacket is armor which is above the insulation, we will see quickly. So, this jacket, cable jacket, the function is mechanical protection and environmental resistance, because the cable will draw inside the mine, and this jacket is mostly mechanical, aluminum or steel, aluminum alloy steel, like that. So, it should also withstand the same thing, it should be against abrasion and impact, it should withstand, it should also withstand temperature variations, and it should have ozone resistance, because continuously ozone is being formed, and it should have surface resistivity, it should not age. So, these are the function of cable jacket. So, as you can see, these are physical distribution of mines. As you can see, it is everywhere. There are a lot of machines which are continuously doing mining. There are pumps. This is the electrical substation. From the substation, cables are drawn out in the mines. These cables are going this way. Some cables are very flexible. This has to go back and forth. Okay, so this is a pump. The pump might shift. This is drilling machine. So, the cable low voltage is about up to 1 kV, and medium voltage is up to, so high power equipments 11 kV, 6.6 kV or 3.3 kV. So, this is a typical distribution of cables, and mostly they are 3-phase cables, because high power equipment you should have 3-phase cables, 3-phase supply for high power. More than 10 HP or so, 50 HP etc. will have high power, otherwise the single phase become, and the motors which are balanced operation motors are 3-phase motors. Most of the motors are 3-phase motors, high power motors. So, therefore, there will be 3-phase supply. Very small power motors are single phase motors, because single phase motors are unbalanced and also generate harmonics etc., starting problem. So, there are a lot of other stops. So, looking at the cable structure which we are discussing, as you can see here, there are different layers 1, 2, 3, 4 like that. So, the copper layer, this is stranded, you can see, then comes the copper conductor insulation layer, then ground core, you can see here, this copper conductor is here. By mistake it is written here, this is insulation. So, sometimes what is done is, on the cable there is communication also. There may be optical cables inside, optical fiber tubes, we will talk about it later on, and there is sheath, outer sheath and inner sheath, which is basically galvanized steel. So, you can see in this cross section, forget about this, come to here. So, this is copper, there is insulation here, this whole thing is insulation, here is insulation, then these are fiber optic cables are there, some fiber optic cables will be here, then this is armor, again outer is there. So, this copper conductor is inside, this is what, then this is the outer sheath, not this is the outer sheath. So, this is a 3-phase cable, typical 3-phase cable, alright. So, and the polyethylene outer sheath is also there. So, this is the cable structure. Sometimes above this also there will be an outer sheath. So, inner sheath is chlorinated material, CM, it is called CM, inner sheath. Then there is something called Kevlar braided reinforcement, is a high strength aramid fiber braid from Kevlar, a product of DuPont, used inside the cables to provide exceptional tensile strength. So, it gives lot of tensile strength, impact resistance and durability without adding. Then ethylene propylene rubber, that is called EPR insulation. So, EPR is a flexible rubber like polymer, so it is used as insulation material. So, this is how the cable looks like, here EPR insulation here. So, copper cables, insulation 1, insulation 2, then outer sheath here. There are some mistakes here. This is outer sheath, this is copper, then this is insulation here, then there are optical fiber tubes somewhere here. These are optical fiber tubes, these are optical fiber, you can see these are optical fibers, these are all optical fibers as you can see. So, this is having both power and communication together, power and fiber optic communication. Fiber optic communication does not distort by power, okay, because this is optical light communication. So, fiber optic communication. Okay. So, you consider this. So, these are some of the which layer does what. First of all, conductor, which is basically copper you saw, it carries current in ohmic conduction. Then insulation prevents leakage, dielectric field control, that means it controls the electric field strength, not breakdown. And there is a screen which will smooth the electric field. We will see why screening is required, because if there is a conductor here, so this conductor will have radial electric field. It will have radial electric field, it will affect others, it will go to all infinity. So, if you put a conductor, if you put a conductor after the insulation, so you put insulation here. So, this is insulation material, around that you put insulation, but above that you can put a conductor again. This is a conductor. This conductor, let me change the. If you put a conductor here, conducting material here, this is conducting material black. So, the electric field will go and terminate here. If there is a conducting material, electric field will terminate here, it cannot pass through it, it will get short circuited. Okay. So, this is conducting. The property of conductor is electric field will be uniform everywhere. So, there cannot be, so electric field will become, so therefore, it will become 0, no. So, this is called shielding, electric field shielding, we will talk about it later on. Then you have armor, which is for mechanical protection, it will be outside. Then there is a sheath, which is for environmental protection, and there is a earth core, which is a earthing wire which will run through it to see the fault current path. So, that may be there, and there is a pilot core for monitoring. This is another small cable running which might be used for signal transmission. So, thank you very much. So, we will go to the next lecture.